Hello, everyone. I'm Frank, and welcome to Frank Puzzles. And this is today's challenging level puzzle. And it's called Present Tense by Nell Gwynn. This is a lot of, well, okay. I guess this is one type that I've never done before, which is we have balanced Sudoku, where we need to place the digits -4 to 4 once each in every row, column, and box. How do we designate a -4? Hold on, I'm gonna take a. Okay, for the answer check, enter the absolute value of each digit. Absolute value of each digit. Okay. So then, yeah, we don't. Okay, so I guess we designate positives as green and negatives as blue. I guess we could do that. Okay, so we need to place the digits -4 to 4 once each in every row, column, and box. We have arrows, where digits along arrows must sum to the number in the circle or ovals. And two-digit numbers are written in the balanced nonary numeral system. Okay, where the first digit is multiplied by 9. Interesting. Okay. So it's a two-digit number written in a balanced nonary numeral system where the first digit is multiplied by 9. So it's not multiplied by 10. So it's not your typical two-digit number. So, for example, if you had -3 here, oops, -3, and this was 6, the first digit would be multiplied by 9, and then you sum the two digits together. So that would be -3 times 9, which is -27, plus 6, which would be -21. Oh, that's weird. Okay. Oh, you can't have a 6. It's okay, so say it's -3 to 4. Then it would be -27 plus 4, which would be -23. Oh, that's weird. Okay. So this is not your typical two-digit number. It's basically the first digit is multiplied by 9, and then you add it to the second digit. And it's left to right and top to bottom. So the top is the digit that's multiplied, but is the first digit, and the left digit is the first digit, which would be multiplied by 9. Interesting. And each reddish line must be divided into one, and these are 10 lines. Each reddish line must be divided into one or more non-overlapping segments that sum to 10. That's interesting. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. So basically, okay, I guess I should explain 10 lines a little bit. Well, it's a little weird with the balanced Sudoku. But basically, you have to divide every tens line into segments which add up to 10. It could technically be the entire segment, right? But every cell that's part of the line must add up to 10. So technically, you could have, I don't know, 5 digits here adding up to 10, 3 digits here adding up to 10, and then these 5 adding up to 10. And you cannot have overlap in the segments, and every part of the line must be part of a segment that does add up to 10. So keep that in mind. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. 4 digits in the same box, and they must add up to 10 at least once. It has to be the digits 1 through 4. So these are all the positive digits, which means all the other digits are 0 through 4 in the negative direction. So these are the positive ones. That means, okay, so this is the sum of 2 digits, and the first part must be multiplied by 9. Ew. So say you had 2 times 9 and a negative digit. 2 times negative 4 at most. 2 times 9 is 18 plus a negative 4, which would be 14. But 2 digits in balanced Sudoku can only add up to at most 7. So this can never be 2 or higher. This has to be a 1. So this is 1, which eliminates 1 here, 1 here, 1 here. We have to have... So... This is at least... So it's 9. You have to have a negative with it, because 2 digits can never add up to 9 in balanced Sudoku. You add up to at most 7. So this has to be negative, and it's negative 2, 3, or 4 here. So these both must be positive, because the most for a single digit is 4. If this is going to be at least 1 times 9, which is 9, minus 4, which is 5 at least. So these are both positive, which eliminates positive in the rest of the box. So this has to be 2, 3, or 4 here positive. We're going to make pink zeros, essentially. So this is pink and blue. In column 1, we have pink and blues also. So 9 minus 2 is 7. It could be 3, 4. 9 minus 3 is 6. It could be 2, 4. And 9 minus 4 is... yeah. So these are all positive. Can you ever... So for 4 digits... So these are 4 digits here. This is a lot of digits here. Can you ever have 3 is the question, right? 3 times 9 is 27. Minus 4 plus a negative 4 is 23. This is at most 3, 4, and 3, 4. So no, this has to be 2 then. So this is 2, which means this cannot be 2 here. This is 3 and 4. Therefore, we have a guaranteed 2 here. So it's either 2, 3, which adds up to 5, which would be 9 minus 4. Or it's 2, 4, which makes this not 2. So this is 3, 4 negative. So 2 times 9 is 18. Minus 4 means a minimum. Sorry, a maximum of... No, a minimum of 14. And that is what the maximum of this arrow can be. So this is 3, 4 as a pair. So this has to be negative 4. Since this is negative 4, this must be negative 3. 9 minus 3 then is 6, so this must be a 2, 4 pair, which eliminates 2, 4 in the rest of the column. So this can't be positive 4, it's 3, which means this is positive 4 here. This is a 3, 4 pair, And this can't be 3 because of 3 in the row. So this is 4, this is 3. This can't be 4, so that's 3 and 4 there. Okay. So again, 2 times 9 is 18. Minus 4 is 14, which is what 3, 4, 3, 4 can add up to at most. And that's the least this could be. So this is at least at 36 minus 2. So this is at least 34. This is 27 minus 2, at least 25. Oh, that's interesting. This is 1, 2, 3, 4. Okay, so this is 1, 2, 3, 4 at most. That's 10. 1, 2 at most here. 4, 1, 2, 3, 4 at most here. 23. And then this is 1 or 2. So this has to be 25. This is 1 or 2 at most here. So 2 at most here. 1, 2, 3, 4 at most here. 1, 2 at most here. And 1, 2, 3, 4 at most here. That's 10, 20, 3, 25 at most. And this is 25 at least, right? 3 times 9 is 27, minus 2, plus a negative 2 at the lowest. So that's 25 then at lowest. So it must add up to 24 here. Sorry, 25 here. So this has to be a 2. So this is 2. This is 1, 2, 3, 4 here. This is 1, 2. And it has to be 0. This is 0, 1, 2, 3, 4, 5. Because if you have negative, then that subtracts things out. So this is 0, 1, 2, 3, 4, 5. These are all blue. This is 0, 1, 2. So green and red. These are all green, which eliminates. So these are green and pink. That we have 5 of them, which accounts for 0 through 4. So the rest are all blue. So this cannot be pink. These are all blue. These are all blue. This is blue. So we have a pink in one of these 3 and one of these 3. We have 5 greens and pinks in row 2, which eliminates greens and pinks in the rest of the row. This can't be pink. This is blue. This can't be pink. It's blue or green. These are all blue here. Therefore, where is the pink in box 1, which is here? It's 0, which means this cannot be pink. This is blue. Where's 4 in box 1? Can't be here, so it must be here. Where's 2 in box 1 then? It can't be here now, so it's here. So this becomes a 1, 3 pair. That eliminates, this 3 eliminates 3 here, so that's 1 and 3. We have all the greens in column 2, so these can't be green, so these are blue or pink. This has to be negative 2 here. So this is negative 2 there. Therefore, we're guaranteed a 0 here. Remaining digits in column 1, we are missing negative 1, 2, and 4. Okay. Therefore, negative 3 has to be one of these two. Therefore, this can't be negative 3 here. We have to have 3 and 4 here. We don't know where the last one is. This is negative something, and 8. So we don't know where this ends right now. Again, so this is 4 times 9, which is 36, plus a negative 1 at best. Sorry, at least. So that's 35 at least. So this could be 10, 20, 30, 3. Again, 10, 20, 30. Oh, it can't be 30. Let's do 1, 3. So that's 4, 10, 20, 24, plus 8, 32, plus 1 and 2, 35. So this is at most 35. So this has to be the -1, because that's the minimum this could be, and that's the maximum the arrow could add up to. This has to be not blue, this is 0. So this must be 1, 3 as a pair. This is green, 1, 3. This must be blue, it cannot be 0. So 1, 3, these are 0 through 4. Sorry, yeah, 0 through 4. Which means the rest of the box is all negative. This must be 1 and 2. And this has to be the 1, because it sees the positive 2, 1, 2, 2, 3, and 4. And so this is the 2. This must be 0, 1, 3, 4. So we've got green and pink. This has to be the all 1 through 4. So the rest of box 6 is blue. The rest of box 5 is blue and pink. And the rest of box 9 is blue and pink. Okay, so this pink eliminates pink here. We have 5 greens and pinks in column 4. So this cannot be green or pink. It's therefore, this is blue. We have 4 green and pinks in column 5. So these must not be pink. These all have to be green. So where is the pink in column 5? It must be one of these two cells, so this can't be pink here. This is blue. So one of these is 3, one of these is 0. This can't be 3, so it must be 0. Which makes this not pink. So this is 3 here. This 0 eliminates 0 here. These can't be 0. Where is the 0 in box 3? It has to be here. So this is 0, 3, 4. This has to be a 1, 2 pair. This is 1 or 2 here. This is 1, 3 as a pair. We have only -2 and -3 remaining in column 3. We have 1 remaining as a positive digit in row 3, 2 here. We have 0, 3, and 4 remaining. This is 3 or 4. So 3 or 4 is guaranteed to be here. This is 0, 3, or 4. These cannot be 0 here, so these are both negative. We have three negatives in column 8, so this has to be negative here. Which means one of these two is a negative. Or sorry, one of these two is 0 and the other one's negative. 2 cannot be here, 2 cannot be here, 2 has to be here. Remaining digits in box 9 are 1, 3, 4. Obviously 3 cannot be here because of 3 in the row. This is 2. This 4 eliminates 4 in the rest of this row. So where is, we have also, right, we have 1, 2, 3 positive in row 5, so this cannot be pink. This has to be the last positive. This is 4. We have 4 negatives already, so this can't be negative. This is 0, which means this can't be 0 here. So this must be a 0, 1, 3 triplet in row 6. This is 0 here. In row 7, we only have 3 positives, so this cannot be 0. This must be positive. In row 8, we have 4 positives. So this can't be positive. This is 0, which means this can't be 0. This is positive. This 0 eliminates 0 in the rest of the row. So these are both negative. This is 0 again. Where is 0 in box 9? It has to be here. So this is not 0. This is 0 here, which eliminates 0 here, which makes this 0 here. So this cannot be 0 here, no 0 here. This 4 eliminates 4 here, and it has to be, cannot be 0, so this is 3. This can't be 0 or 3, it's 1. So no 1 here, no 3 here, no 3 here. This is 1 or 2, this is 1, 2, or 4. This is 1, 2, or 4. Cannot be 2 because of 2 in the column. Sorry, 2 in the row. Okay, remaining digits then. So then we have sum that adds up to 10. This is at least -1, -1. Okay. This is interesting. Okay, this is -1 through 4 here. This cannot be -1 or -3, so it's -2 and 4. Okay, so this cannot be -4 here. Because this is at least -4. So then this must be -2, which means this is not -2, this is -4. These are -1 and 3. We don't know which one's which. This can't be -4. This can't be -4. So this must be -2 plus -1, which makes -3, or -2 plus -2, which makes -4. Okay. Remaining digits, remaining negative digits in column 2 are -1, 3, and 4. -1, 3, and 4, -1, 3, and 4. This is -1 through 4, -1 through 4, -1 through 4. -1 through 4 here. -1, 2, 3, -1, 2, 3, and one of these is a 2. This is -1 through 4, -1 through 4 with no 2 here. So you're guaranteed a -4 in one of these spots. Okay. This is at least guaranteed to be -6. What's the most this could be now, then? So we're guaranteed -6, -7, no, -6, and then -1, 3, so that's -10, -12, at least. That leaves us, so -12, this is 12 at least. We have 12 at most here. 12, 3, 4, 3. And it has to add up to 10 once. So therefore, that has to be the minimum of 1, right? We only have 12 here. This adds up to at most 10. We have a guaranteed -12 already on the line, right? 1 and 3, that's 4. -1, 2, 3, that's -6 plus -4 is -10. And -1, -1 is -12. Well, this is 12 here. This can only be 3, 4, 3, 4. So 3, 4, 3 is the max, and therefore must be the max. So this is not green, this is pink. This can't be pink. So this is green. So this must be 3, 4, 3. 4 eliminates 4 here, so that's 1. This is 0, no 0 here. This is 4 and 0. This has to be a 1, 3 pair, so this cannot be negative 2, which means negative 2 is here. This has to be negative 1, 2, and 3 to add up to negative 6. And this must be negative 1 and negative 1. So this can't be negative 1 anymore here. No negative 1 here. This is a 1, 3 pair. Negative 1, 3. 2 eliminates 2 here and here. This is a negative 1, 2, 3 triplet in box 9, which eliminates negative 1, 2, and 3 in the rest of the box. So this is negative 4 here, which means this can't be negative 4, so this is negative 4 here. Okay. That means this is negative 2 or 3. And we have negative 2, 3, or 4 here. Negative 4 eliminates negative 4 here. So one of these two digits is negative 4. Therefore, this can't be negative 4 here. One of these two digits is negative 4. This can't be... It could be... One of these two digits cannot be negative 4, so one of these two digits must be negative 4. This cannot be negative 3 or negative 4, so this is negative 1 or 2. Cannot be negative 1 because of negative 1 in the box, so this is negative 2. That eliminates negative 2 here. This has to be negative 3 and 4. This negative 2 eliminates negative 2 here, so this is negative 3. Not negative 3, this is negative 1. No negative 1, 2, or 3, so this is 4. Negative 2 here. No negative 2 here. This negative 2 eliminates negative 2 here, so this is negative 1. No negative 1 here. We have a negative 3, 4 pair in row 8, which eliminates negative 3 and 4 in the rest of the row. This can't be negative 3. This is negative 2. This is negative 1. This is negative 3 then, which eliminates negative 3 here, so it's negative 1, negative 3. Negative 3 eliminates negative 3 here, so this is negative 1. Negative 1 eliminates negative 1 here, so it's negative 3. Negative 3 eliminates negative 3 here, so it's negative 4. No negative 3 or negative 4, it's 2. No negative 2, that's negative 3. No negative 3, that's negative 4. No negative 4, that's negative 3. 3 eliminates 3 here, so this is 1 and 3. 4 eliminates 4 here, so it's 2 and 4. This can't be 2 or 4, it's 1, which eliminates 1 here, so it's 4, which eliminates 1 here, it's 2. 1 eliminates 1 here, so it's 2, makes that 1. Negative 1, no negative 1 here, eliminates negative 2, 1 here, so this is negative 2. Negative 2 plus negative 2 is negative 4. Negative 4. This has to be negative 2 here, because this negative 4 eliminates negative 4 here, so it's negative 3. No negative 3 means this is negative 4. No negative 3 or negative 4 means it's negative 1, which leaves this as negative 3. Yeah, not too bad. Definitely not used to the balanced Sudoku. But it's an interesting concept, right? Yeah, I mean, aside from just not being used to it, I get the logic behind it wasn't that hard. There was multiple things that were new, right? It's the what was it? Nonary? The balanced nonary numeral system was interesting. Yeah, I guess that works, but that was interesting. Yeah, but we were very constrained by essentially what, like, for example, the tens digit was very restricted here, obviously. And then it was actually surprisingly restrictive on this line, too. So that was interesting. It was restrictive on the arrows, too, with what you could do. So, overall, very interesting puzzle. I guess I would put it in between easy and challenging. It's not really challenging level difficulty. It's just like that we haven't experienced these type of puzzles before. So anytime you have something new, it's going to be a little bit take you a while to well, you don't have the intuitions built in. But in that sense, it's also good because then you won't make potentially bad errors there too, right? Because you have to go through every step. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.